You're probably aware that there is a massive amount of hype surrounding deep learning at the moment. At the beginning of this unit, I presented some exciting and successful applications, so some of that hype is certainly justified. But it's important to realize that machine learning has experienced this kind of hype in the past and unfortunately has failed to live up to its expectations. Part of the reason is that practitioners tend to oversell the technology, and sometimes they fail to recognize its limitations. Let's take a look at what I mean. Machine learning has actually been around in one form or another for over 50 years. There have been two peaks of interest in AI and machine learning. The first came in the 1960s and 70s, and then again in the 80s during the rise of the expert systems. Both of these periods were followed by AI winters, where not only interest, but also optimism and funding vanished. So it would be wise to be a bit cautious about the current hype. Whether deep learning can live up to our expectations remains to be seen. So although it's important to realize the massive amount of potential in this technique, we also need to be realistic and not play into the hype. A large part of that is being explicitly aware of the limitations of machine learning. In chapter 4 of the book, Francois mentions two implicit hypotheses that we have when performing deep learning, and all machine learning for that matter. We are hypothesizing that 1. Your outputs can be predicted given your inputs, and 2. Your available data is sufficiently informative to learn the relationship between inputs and outputs. I like to think of these as the two golden hypotheses, and they're worth stating explicitly because sometimes we take them for granted. Actually, these hypotheses shouldn't be surprising to you. I'd be hard-pressed to think of a situation when we are not assuming these conditions, when we're developing models of the real world, which is all that a neural network is at the end of the day. Wrapped up in these two hypotheses are issues of low accuracy, confounding variables, small sample sizes, and systematic bias that you're probably already familiar with from other techniques. We'll see these issues come up again when we talk about overfitting later on. Our predictions are only as good as the input we feed into them. Over the past few years, there has been a growing concern about inherent bias in machine learning. Now, there are unfortunately a couple uses of the word bias in deep learning. Bias is the name of a parameter in our models, which we'll see in detail in the next unit. But that's not what we're talking about here. We mean bias in the negative sense, some form of systematic error. This can be inadvertently or purposely introduced into deep learning processes by the data scientist. For example, if we train our model on one type of data and used it on another different type of data. To return to the house prices example, imagine that we develop a really good model. Do you think that the same model would hold true in 1 year's time? Maybe, but we know that we'll need to constantly update our model. So although we don't typically think of that as a systematic error, we know that we can't necessarily apply a model trained on data from 1 year to a test set from another year. Imagine another simple situation. We train a model to distinguish apples and oranges. Then we stick in a picture of a mango. Our model is forced to choose one or the other, so the model makes a nonsense prediction. This is directly related to the two golden hypotheses. Although it may seem obvious, sometimes we forget about these issues. In particular, socio-political aspects of machine learning may often be overlooked. There have been some famous examples where machine learning algorithms fail to recognize the faces of black individuals but have no problem on their white colleagues until they literally put on a white mask. ProPublica, an advocacy group, has also reported that machine learning algorithms are more likely to assign a high-risk score to black criminal offenders as to their Caucasian counterparts, even if their crime record is not as severe. This can be pretty serious because sometimes the inherent bias in our models can have real socio-economic consequences. But even if they don't, there's no reason why we'd want to knowingly limit the proper application of our models or reduce their effectiveness. We began this module by talking about the hype surrounding deep learning. I hope that now you, as a future practitioner, have a bit of insight into how you can avoid making extravagant claims. The key take-home message is to always remember the two golden hypotheses. We assume that our outputs can be predicted given our inputs, and that the available data is sufficiently informative for this task. There's just one more brief concept to cover before we get our hands dirty with some coding exercises. In the next video, I'll cover the 4 varieties of machine learning and wrap up our introduction.